Okay, class, I'm so sorry about that. We got interrupted there briefly. Some technical issues. Okay, so let's go back to, we're looking at what happens if the lines never cross, and what happens if the lines are right on top of each other. So I have a little graph got erased here too. Let's regraph these. I'll put them in slope-intercept. Okay, so I'm going to solve for y. So we would have negative y equals negative 2x plus 4. So I just move the 2x over. Now I'm going to multiply everything by negative 1 to get that y positive. Y equals 2x minus 4. Okay, so there's my first equation. I'm going to go up 4. Nope, down 4. It's negative 4. You're going up 2 to the right 1. Up 2 to the right 1. To get us lots of good points. There's our first line. Right here. Okay, second line I'll do it in orange. I'm going to do the same thing. I'm going to put that into slope-intercept. We will have negative 3y equals negative 6x minus 9. Divide everything by negative 3y, or negative 3. So y will equal 2x plus 3. So here the y-intercept is 3. Our slope again is 2. And there we are, connecting all of those points. Notice slope was 2. Slope was 2. So even without graphing them, since they have the same slope, we know they are parallel. They're never going to intersect. Here, our final answer would be no solution. That system, so this system of equations, if they are parallel, the system has no solution. Okay, let's look at our second example. Again, let's do cover-up method. So I'm going to say 4x equals 8. So x will equal 2 for my first one. And then we will say negative 2y equals 8. I'm going to divide by negative 2. Y equals negative 4. So down 1, 2, 3, 4. I'm going to connect those. That was my first line. I used the cover-up method. Second line I'm going to do in pink. Okay, so my y-intercept for this one, b equals negative 4. Slope is 2. I'm going down 4. Oh, look at there. Up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. Interesting. What do we notice about these lines? They overlap. So this system, these two lines are the same, and we have infinitely many, so there's my infinity sign, infinitely many solutions. That is an example of one of each of those, a no solution and an infinitely many. Okay, so that's the first step. Second type of questions, those were graphing equations. Now we're going to be graphing systems of linear inequalities. Okay, so remember inequality, we're going to be shading. And there's either a solid or dotted line. Since we have shading here, it is very important to use a pencil or something you can erase with. You might have some of those fancy pens that erase, that's fine. But you probably will want to be able to erase for these problems. And let's look at why. So we're going to have multiple equations, and you're going to have to shade for both of those equations. So use a pencil. You originally, whenever you graph each inequality, you want to shade lightly. And then at the very end, we're going to shade where the shading of both problems overlaps. All right, sounds kind of complicated. It might look crazy at first, but we're going to do the exact same thing. We're just going to graph the two inequalities. Okay, so this first one, I'm going to graph in red. maybe. I'm going to use the cover-up method. We would have x equals 5 and y equals 5. So up 1, 2, 3, 4, 5. To the right 1, 2, 3, 4, 5. Okay, so is this going to be solid or dotted? It's going to be dotted because there's no equal to sign. And then this is less than, so we are shading below. We'll do an arrow down. So I'm going to do a little dotted line and then shade lightly. So I'm just going to do a couple of red stripes below this. If you have pencil, you can shade the whole entire thing lightly. It's kind of hard for me to do. Or I can take this highlighter and highlight all of my space, and we will see where these two equations overlap. So next, we need to graph y is less than 2x minus 1. So I see that's in slope-intercept, so I know that my intercept is -1 and my slope is 2. So I'm going to graph that. You're going to graph right on top of what you just graphed. So down 1 with your y-intercept. Then our slope, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. You can also go down. Okay, is this going to be solid or dotted? Look at your sign. It's dotted. And then are we shading above or below? This is y is less than, so again, less than is below. So we're going to dot this and then shade below. So there, or let's say I did use the highlighter here. Okay, the catch here is that our only answer is where the shadings overlap. Okay, so you want to find where is there green and red, and that is your final shaded answer. So here, if you use a pencil, that's where it's easy. You can erase everything where the two shades do not overlap. So over here, all of this red can be erased. We did not overlap in that section of our graph. Over here, the green and the red did not overlap. Okay, so our shaded section should be below both lines, almost the entire bottom right quadrant, and that is what our graph would look like shaded in. Okay, and then we want two possible solutions. So we want solutions that are in this shaded area. Can the solutions be on the lines? Why or why not? Okay, so hopefully you thought to yourself they cannot be on the lines because those lines are dotted. So let's pick two in the shaded area. So I know -2, or 2, -2, and then 2, -3. I shaded mine in black so they're really dark. But if you think about here's 2, -2 is about there, 2, -3 is about there. So those are the 2 points that I picked. Okay, let's look at number 9. So we're going to do the same thing. Graph each one separately and then see where it overlaps. So I'm going to use the cover-up method. 2x equals 6, so x equals 3. And then we have -3y equals 6, so y equals -2. If you want, it can help you. You can count the slope from here, so it's up 2 to the right 3. You can get a couple more points. And is this solid or dotted? So I see that it is equal to, so this is going to be solid. And there we're shading above or below. Remember, check the sign in front of our y. So we have a -3y. So flip our sign, and we are going to be shading above. So that's tricky. -y means flip your sign. So solid, and I'm going to shade above. Okay. And then let's go light blue. I'm going to use the cover-up method again. 2x equals 2, so x equals 1, y equals 2. So here I see my slope is down 2 to the right 1. You can use that to draw a couple more points. This is going to be dotted, and we are going to shade below because we have less than. So dot, shading below the whole entire line. So think, where does the pink and the blue intersect? I'm going to highlight in purple because pink and blue mixed together gives us purple. That section is all right here. Okay. Now possible solutions. So easy points I see 0, 0. -1, 0. Very, very simple. Okay, and then some questions I have for you. Think about, could this point, -4, -4 be a solution? So could -4, -4 be a solution? Yes, because solid line. What about the point 0, 2? That would be no, because of dotted line. Okay, so always make sure you're choosing points that are in the correct area. Okay, on the next page, we've got some try-its. 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and let's just have you try all odd problems. Okay, try the odd problems. You can check your answers in the Google Classroom, so the filled out notes are posted in the Google Classroom. Try the odd. If you need extra practice, you can do the even as well and check your answers in the Google Classroom. Once you've completed those, come get the homework from Miss Boland, and that'll be what you'll work on for the rest of the class. Sorry that got split up into 2 videos and it was a little long. Let Miss Boland know if you have any, or let me know, that's kind of weird talking in third person. Let me know if you have any questions, if I need to talk you through graphing again, we can work on that. Alright, good luck, guys.